Hello everyone, so today we're going to find the derivative of sine x using first principles. Feel free to pause the video and attempt to solve it yourself first before we solve it together. So our first step is crucial and very essential since it will help guide you. So the derivative of f of x using first principles is equal to the limit as h approaches 0 f of x plus h minus f of x over h. Writing this formula down will help guide you and avoid confusion in your further steps. So now let's move on. So the f derivative of x will be equal to the limit as h approaches 0 sine of x plus h, minus sine x over h. And now using identities, we can expand sine of x plus h. If you don't know what identities are, please look at the link to a video in the description below. So f prime of x is equal to the limit as h approaches. This will be equal to f derivative of x will be equal to expanding sine of x plus h using trig identities will give you, so first write the limits as h approaches 0 sine x cos h plus cos x sine h minus sine x over h. Our next step would be to simplify this expression. So you can see there's sine x here and here. So this would be sine x cos h minus sine x plus cos x sine h over h. If you factor sine x outside of this, all I did is rearrange it: sine x cos h minus sine x plus cos x sine h. So factor sine x out of this, f prime of x will be equal to the limit as h approaches 0 sine x, which will be cos of h minus 1 plus cos x sine h over h. So this over here is the step we ended with in the previous page. Okay, so moving on, f prime of x is equal to the limit as h approaches 0 of sine x into cos h minus 1 plus cos x sine h over h. Now this limit is a limit to the whole fraction over here, and what we notice is we can split this fraction into two smaller fractions. So this will give us f prime of x is equal to the limit as h approaches 0 of sine x into cos h minus 1 over h plus cos x sine h over h. Okay, so now f prime of x is equal to the limit as h approaches 0 for sine x cos h minus 1 over h plus the limit as h approaches 0 for cos x sine h over h. All I've done is I've multiplied each fraction, or really multiplied each fraction, but taken the limit to each fraction individually. And this doesn't break any mathematical laws, just in case you're wondering whether or not it does. What we observe is the limit h approaches 0 only affects values that have h in it, or rather numbers that have h in it. since the limit will not affect the values of cos x or sin x. So we can take it outside of the limit. So this will be equal to sin x limit as h approaches 0 of cos h minus 1 over h plus cos x limit as h approaches 0 of sin h over h. This is f prime of x. So this is the equation we ended with in the previous page. So f prime of x is equal to sin x, the limit as h approaches 0, cos h minus 1 over h, plus cos x, the limit as h approaches 0 of sin h over h. So now I want us to address just sin h over h as the limit of h approaches 0. We're supposed to know that. So in this case, we're going to take h in terms of radians, which is another way of measuring angles. There's two ways to measuring angles: radians and degrees. And for this case, we're going to take h in radians. So as h approaches 0 or very small values, we can approximate and say that sin h is equal to h. Sin h is equal to h for very small values of h. And since h is approaching 0, we can say that h is a very small value, around 0.000000001. And if you were to put this in your GDC or your calculator, you would find that sin of h of this number over here will be roughly equal to h. And this would only work if your GDC is in radians or your calculator is in radians. So if these two values can approximately be equal, we can say that this is equal to 1, meaning this term over here would dissolve down to cos x. But now for the case of cos h minus 1 over h, let's put the limit down. The limit as h approaches 0 of cos h minus 1 over h. In this case, the value of cos h as h approaches very small values like 0.0000001 would be equal to 1. Cos of values that are very close to 0 is equal to 1, and 1 minus 1 is equal to 0, and this would be 0 divided by h, which would also be equal to 0. Hence this term over here would dissolve down to nothing but 0. Okay, so now since we know that the limit as h approaches 0 of cos h minus 1 over h is equal to 0, and the limit as h approaches 0 of sin h over h is equal to 1, we can safely say that the f prime of x is equal to sin x times 0 plus cos x times 1. Hence the derivative of sin x is equal to cos x. Also, if you're taking the IB, you don't have to explain how the limit as h approaches 0 of cos h minus 1 over h equals to 0, how the limit of h as h approaches 0 of sin h over h is equal to 1. This was just to gauge your understanding of the concept. So in the end, the derivative of sin x is equal to cos x. Thank you for watching our video. Please like and subscribe to our channel.